Welcome to this talk on Spring Cloud on Kubernetes. How did everyone enjoy the keynotes? Yes? Are you guys all here because of all the talk about Kubernetes? You changed your mind? Yeah. Okay. We both appreciate you guys coming. It's really exciting to see so many people here to hear this talk. So with that, let's get started. We have a lot of content to cover. We hope to give you guys some opportunity to answer some ask some questions at the end. So we want to make sure we have enough time. This is the best slide in the presentation right here. Please read it very fast because I'm about to change it in about 2 seconds. So who am I? I wish I knew. My name is Ryan Baxter. I'm a software engineer on the Spring Cloud team at Pivotal. So I work on various different Spring Cloud related projects, everything from Spring Cloud Netflix to Spring Cloud Kubernetes, obviously, the config server. I've had my hand in the latest and greatest circuit breaker project. So various different things in my time at Pivotal. I've been at Pivotal for about 3 years. Before that, I worked at a very small company called IBM. When I'm not writing code or working, I have a family that keeps me fairly busy. So I have 2 little kids, a daughter and a son, and my wife also. So that's a little bit about me. I'll let Alex introduce himself.
Hi everyone, my name's Alexandre. As you may heard, I'm French. I'm from Paris. I work as a platform architect working at Pivotal Paris. And my job is to help our customers to use Pivotal solutions, such as the Pivotal platform, but also the Spring framework, the Spring Cloud, and everything we have in the Pivotal services marketplace. So I joined the company 1 year ago. This is my first time here in Austin, first time participating to Spring One platform. I'm very happy to be here and to show with Ryan what we can do with Spring Cloud Kubernetes. Thank you, everyone.
Thanks, Alex. And as you heard, I am not French. So, so this is just what we're going to talk about today. We're going to talk about what is Spring Cloud Kubernetes, give you a little background there. Most of the time is going to be spent giving demos, which I'm sure you all appreciate. And then we're going to talk a little bit about something called native Kubernetes implementations at the end, just to talk about something a little bit different. Let's get started. So as developers, we have a lot of choices around the various technologies we use, right? And one of those choices we have to decide is where are we going to deploy our applications to, right? And this used to be a very simple choice. Even just a few years ago when I got into the cloud space, this diagram looked far simpler. There were really kind of only 2 pieces there. There was infrastructure as a service and platform as a service. And it's grown. It seems like every year there's something new here that we add, right? And the platform, the type of platform we choose is really just, the only difference is the level of control we're giving up to the platform versus the level of control or what we control as the developer, right? So if we go to one extreme, I think everyone's familiar with at this point is infrastructure as a service, right? Where the platform provides the hardware and the virtualization, and then we get to control everything from the operating system up, right? And you go to the other extreme where we have functions as a service where basically the only thing we're deploying is a small piece of code, not even an entire application, and the platform controls everything below that, right? So it's about what you want to have control over and what you don't want to have control over. But in between, we have 2 different choices, right? So I think everyone's familiar with platform as a service at this point, i.e. Cloud Foundry. I think most people are familiar with that. But there's this in-between state between platform as a service and infrastructure as a service, and that's containers as a service. And generally, these platform as a service are actually using containers under the covers, right? You can see that as one of the layers there. But if you want to, containers have a lot of advantages, especially for specific types of applications that might need a little bit more control about their environment that they're running in, and they're nice and portable, and they can easily be moved from one environment to the next. So they have a lot of advantages. But from a Spring Cloud perspective, we've never really cared, right? I don't care if you want to run on an infrastructure as a service, or you're going to run on some bare metal hardware that you have underneath your desk in your office. So we have solutions for all these different various platforms, and we generally integrate pretty well with the various different cloud providers. The other thing that's pretty cool when we start to talk about containers is that it's very easy to get boot apps running inside of a Docker container, for example, right? If you go to this URL here, we have a nice guide up on the Spring Guide site that shows you how to Dockerize a boot application. And the things we love about Spring Boot, right, this is the guide here. Oh, nope, that's not the guide. This is the guide. The things that we love about Spring Boot make it very easy to put it in a Docker container, right? Because after you do your Maven or Gradle build, what you end up with is a jar file, and all you got to do is java-jar and execute that jar file, and the app starts up, right? So your Docker file to get the app running really only requires a JDK, and once you have the JDK there in the container, the app runs, right? That's the only requirement. So you can see here, just to Dockerize, quote unquote, a boot app is fairly simple. It doesn't take much to do it. So that's all well and good, but in a cloud architecture where we have, not just one of these containers or two of these containers, we have potentially hundreds of these containers. You're left, what do you do with all of them, right? How do you manage these containers, right? How do you make sure that they're all running? How do you make sure they're healthy? How do you make sure if something happens to one of them that it automatically gets restarted? How do you make sure that, how do you do all the networking between all the containers, right? All this stuff is something that Docker doesn't solve out of the box. It just provides you with a container, right? But if you have lots of these containers, what do you do, right? So that's where Kubernetes comes in. Kubernetes is kind of imagine it as your container management system, right? Who here is already familiar using Kubernetes today? Wow, a lot of you guys. Cool. So, a lot of you already know what Kubernetes is, right? So we can deploy all our containers there and run our apps, and it takes care of all that hard stuff that we don't really want to have to worry about as developers. But when we think about layering, not just running boot apps in Kubernetes, but also adding Spring Cloud on top of that, what does that look like? Well, it's kind of up until recently, it's been kind of a iffy situation, right? If you're familiar with some of the traditional Spring Cloud stuff, we have things like Spring Cloud Netflix, which has a Eureka server, which provides service discovery and a service registry. We have a ribbon there for load balancing. We have some circuit breaker stuff, right? We have a config server that externalizes configuration. But when you look at Kubernetes and you start to learn more about what Kubernetes provides, well, it provides a lot of this stuff already, right? It has the concept of a service registry and service discovery. It has the concept of externalizing configuration via config maps and secrets. It does load balancing to some extent at the service layer, right? So it has a lot of these things already there in it, right? But if you're also familiar with Spring Cloud, we know that we've abstracted a lot of these concepts out, right? We have interfaces for some of these things. And we have different implementations. It's not just Spring Cloud Netflix that provides the implementation. We have things like Zookeeper and Consul and other things, and integration with other cloud platforms that implement all these interfaces. So as you move your applications around, right, we don't care. Your code doesn't have to change depending on the platform you're running on. We just adapt and make it work. So this is where Spring Cloud Kubernetes comes in, and Alex is going to tell you a little bit about that.
Thanks, Ryan. So what is Spring Cloud Kubernetes? So it's time to go deep dive on this framework and see what we can do with this framework. So the idea is to write portable apps using Spring Cloud. As soon as you start using Spring Boot, as soon as you add the Spring Cloud Kubernetes to your project as a dependency, that's all the things that you need to do. You don't need to update your source code. You don't need to adapt your application in order to deploy your application to Spring Cloud, to Kubernetes. And this is a great feature because you just keep the same source code, and you can just deploy your application to Kubernetes with no time, with very ease. And no matter which environment you use, using Spring Cloud, you have the right abstraction, platform abstraction, to do this. And the good thing with Spring Cloud Kubernetes is that it provides a seamless integration with everything you know about Spring Boot and Spring Cloud. You don't need to learn new features. You don't need to relearn everything that you've done with Spring Boot. If you know how to develop a Spring Boot app, then you already know how to leverage Spring Cloud Kubernetes. And Spring Cloud Kubernetes is available, published since early this year. So let's go into details and see what we can do. First things, using Spring Cloud Kubernetes, you have native config map and secret support with your application, which means that as soon as you edit a config map file with your Kubernetes clusters, then your application will be able to read this configuration. The only thing you need to do is to just use the thing that you already do with Spring Boot. So just use add value, just use add configuration properties, just like the thing that you already know about Spring Boot. And using Spring Cloud Kubernetes, you have native support for reading this config map that you use with kubectl. And the same thing is with secret to load credentials for your application. And a nice feature from Spring Cloud Kubernetes is that as soon as you update your config map, you have the ability to automatically reload your application, which means that you don't even need to kill your pod or to redeploy the whole application. You can just apply the new configuration live without reloading your application. That's a nice feature. Another nice feature from Spring Cloud Kubernetes is native service discovery, which means that when you have many Kubernetes services that you declare within your application, then using Spring Cloud Kubernetes, you have a discovery client implementation coming for free, which means that you don't even need to deploy Netflix Eureka server to your Kubernetes cluster. The only thing you need to do is to add the Spring Cloud Kubernetes dependency with your application. And then, as soon as you use the @load balanced annotation, or if you are using the discovery client service available in Spring Boot and Spring Cloud, then you will automatically discover available services within your Kubernetes cluster. And there is nothing else to do to leverage this. And the nice thing about Spring Cloud Kubernetes, it's that it's already leveraging the new Spring Cloud circuit breaker abstraction, which means that you can just leverage Netflix Istrix and Resilience4j for your application, just by reusing everything you already know about Spring Boot and Spring Cloud. And the nice thing about Spring Cloud Kubernetes is that you also have access to the pod health indicator, which means that using this endpoint, you will know if your application is running fine. So you will have access to all environment variables that are made available to your application. And you have a quick peek about what's going on with your pod. Is this pod running? Is everything OK? Just hit the /actuator/health, and you have everything you need to know about your application running on Kubernetes. The last thing I wanted to show you is the fact that if you need to provide custom configuration for your application, then the only thing you need to know to do is to create a file, application-kubernetes.yaml or .properties, and you're done. Sometimes you need to provide custom configuration for your application. And if you need to set specific properties that are only available and only enabled if your application is running with Kubernetes, then this is the way to do. Just create this file, and as soon as the application will start, this configuration will be loaded for you, and you have nothing else to do. So enough talking. This was a quick introduction to Spring Cloud Kubernetes, and we are about to run a demo with Ryan. And what you're about to see is how to deploy a cloud-native application to Kubernetes, leveraging deployment generation. So you'll see how to deploy an application without ever writing a YAML file. You'll see service discovery in action. And we will also show you how to do load balancing within your Kubernetes cluster, and also config map support with the application. So now, back to you, Ryan. It's demo time.
Thanks, Alex. All right. So if at any point you can't see something and you want to see something, just yell at me and let me know, and I can make things bigger or try to explain it. So I'll do the best I can here. So we have a couple of basic applications here. It's just kind of fictional e-commerce microservices applications. Just has a couple of services. I know you can't see probably some of the project layout here, but I'll describe it. It's very basic. There's 3 different services. There's a fashion service, a hot deal service, and a toy service. Each one of these services just returns some products, right? Some fashion items, some toys, or some items that might be on sale via the hot deal service, right? And these are basic boot apps. There's nothing special about them. Each one of them looks pretty much exactly the same. There is your main application here, and then there's a REST controller that just returns a static list of items here. Okay, so nothing fancy going on in any of those apps. The 4th app is a gateway, which is leveraging Spring Cloud Gateway, which we just heard about a little bit about in the keynote here. There's a lot of other sessions that will go into the details of how to use the gateway and all that stuff. I'm not going to do it today, but basically we just created some routes in our gateway that are going to route traffic from the gateway to these microservices that are sitting behind that. And the gateway also contains its own endpoint here, which is called start page, which basically aggregates all the information from the other services together and returns it in one giant response for applications that might want everything in one response instead of having to query each service individually. Does that all make sense to everyone? All right, so right now the app is just using your basic Spring Cloud stuff, right? There's nothing here about Kubernetes or anything, just basic Spring Cloud Netflix stuff. So I'm going to start the apps. They're going to register with a Eureka server that I already have running. We're just going to run them locally, see how they work, so everyone gets an idea about that. And then we're going to show how to take these apps and then get the same apps running on Kubernetes. Okay. So each one of these apps, like I said, is going to start up. They're all going to register with Eureka. And I'll start the gateway as well. Like I said, I have a Eureka server already running here. So this is just running locally on my machine, right? You can see all the apps have registered here as I started up. So nothing crazy going on here. If we look at what these apps do, so if we go to 8081, I got to remember all the right ports for everything. All right. So this is the toys service. Right, it just returns you a JSON array of toys, right? The fashion service is 8082. So if we go to fashion/bestseller at 8082, same deal. And then the hot deal service, if you can see a pattern here in the port, is 8083. All right, so nothing fancy going on there. The gateway, you can then route request to any of those servers. So if I go to /toys/bestseller, you can see I get the information from the toys service. Same thing with the fashion service, right? So these are all the routes that I created in my gateway. And then lastly, the hot deals, right? And then I mentioned also that we have another endpoint called start page on the gateway. So if we go to /start page, you can see we get everything, right? So we have the toys, we have the fashion items, and the hot deals all here, right? So one of the cool things that we have with the gateway is integration. So you can provide resiliency at the gateway level, right? So we've integrated circuit breakers at the gateway. So when we route a request like this to /start page, and everything gets, the gateway makes requests to all the different services, they're all wrapped in a circuit breaker. So if anything goes wrong there, we can provide some resiliency. So one of the, so another tool that I'm using here in the apps, if everyone's familiar with chaos engineering, is this really cool tool called Chaos Monkey for Spring Boot, which basically allows you to implement chaos engineering principles into your Spring Boot apps. So one of the things this tool will do, which is really cool, is just inject random latency into REST controllers, right? So I hit a REST controller, and every so often randomly it's going to hit a delay and be very, very slow to respond, right? So this is one of the areas where you might want to think about providing resiliency in your applications using something like a circuit breaker to trip that circuit breaker when the app is just taking way too long to respond, right? So I'm going to enable Chaos Monkey here on the toys service. So if I make a post request to this Actuator endpoint, you can see that we've enabled Chaos Monkey. So now if I hit 8070/toys/bestseller, randomly, this should take a few seconds to respond. And the best part about random things that happen in demos is you never know when it's going to happen. So you can see here, whoa. Now I really can't see anything here.
That was random.
Okay, that's the first time that has happened in about 3 years of giving live demos. All right. I promise that wasn't part of my chaos engineering. There we go. All right. That was not part of my chaos engineering demo. All right. That should be awesome on the video recording. So you can see here, it took too long to respond. We hit the circuit breaker, got tripped, and we returned an empty array. You could be more creative and return some cache data here if you wanted to. I'm not that creative. But you do see here that we got the fallback response from the gateway, so that's just indicating that we just got a fallback, all right? Now what this looks like when you do, when you hit the start page is that, you'll see here, okay, so there it got tripped, right? So we get this status response in the start page telling us that we hit the fallback, and we get the fallback data and all that stuff, right? So that's basically how the apps work. Anyone have any questions about that before we move on to the next part? All right, cool. You guys are all very smart. Thank you. All right. So now, right, this whole session is about Kubernetes, right? So what we want to do is get these apps running on Kubernetes, right? And in an ideal world, we want to do this just without making any code changes, right? I don't want to touch a single line of code. I just want to maybe manipulate some configuration properties, maybe add a configuration properties file for Kubernetes specifically, and do some stuff that way, right? So obviously, the first thing we need to do here is actually add the Spring Cloud Kubernetes dependency, right? So in our parent POM, we have we're importing the Spring Cloud BOM here, okay? So we have that, or adding that dependency. And so in each of these projects, we need to go ahead and add the dependency for Spring Cloud Kubernetes, right? So we'll add a new dependency here, and it's Spring Cloud Starter Kubernetes, and the group ID is for that. We don't need the version. Okay, so we just add that starter there. And when this starter is on the class path, one of the things that's going to do that Alex had mentioned is that it will automatically detect when it is running in a Kubernetes environment, and it's going to enable that Kubernetes profile. Right, this is going to be important for kind of transitioning things from one environment to the next, right? So right now, we run the app locally, and we want to run the app in Kubernetes, right? So when we run the app locally, so in our default application properties, we're just going to disable Spring Cloud Kubernetes to make sure it's not doing anything, right? So we'll say Spring Cloud Kubernetes enabled false, all right? And we're going to add another configuration properties file here specifically for Kubernetes. So application-kubernetes.yaml, okay? And here, what we're going to do is say, since we're running on Kubernetes, we don't need Eureka anymore, right? We're going to take advantage of the Kubernetes service discovery. So we're going to say Eureka client enabled false, all right? And obviously, in this case, we want to enable Spring Cloud Kubernetes. So we'll say Spring Cloud Kubernetes enabled true, all right? That makes all sense. So that's all we have to do. That's really it, okay? Now this app is ready to be deployed to Kubernetes. We do need to Dockerize this thing, right? We need to put it in a Docker container. Since I told you that every boot app looks exactly the same when creating a Docker container, I've already added Docker files for each one of these things. This, just go to that guide. You can copy and paste that code and throw it in your application. It will work exactly the same. That's basically what I did here. And to save us a bunch of time, I've already built these containers, pushed them to a registry, so that's all done, so we don't have to watch the magic of the network actually take place here live. That's done as well. The other thing we need to deploy something in Kubernetes is generally you'll create a deployment for an app. You'll create a service for an app. You might, as part of doing that, configure health checks. You might add specific environment variables, all this stuff. And the way Kubernetes does all these things is through the magic of YAML. Now, I don't really mind YAML. Like when I have to write this amount of YAML, I don't mind it. But when you do this in Kubernetes, it's a lot of YAML. It's a lot. And every time I need to do it, I have to go back to the Kubernetes documentation, figure out what the right properties are, and type it all in. And it takes me forever, and it's really annoying. But someone told me about this really cool tool that I'm going to use today, just so it's not as annoying, called Decorate. This is specifically for Java apps, and they have some nice integration with Spring Boot. So it inspects things like your application.properties, the POM file. Look at everyone get out their cameras and take a picture of this. It's really cool. I really like it. So it inspects those things, and it will automatically generate the YAML for you for the most part, right? And you can tweak things if it doesn't generate exactly the way you want. But it integrates as part of your Maven build. So when you run Maven clean package or install or whatever, when you run that goal, it will automatically create this YAML file for you. So I'm going to use this tool, and you'll see how much time it's actually going to save us. So I'm just going to go down here, and in our parent POM, I'm going to add another dependency to our dependency management section here for Decorate. So they have a Spring starter specifically. And then I'll go up to our fashion application, and I will add that dependency as well, okay? And the one thing I already know that I'm going to have to tweak about the YAML that it's going to generate, so by default, the service that it creates, the service YAML, is going to be a cluster, service type of cluster IP. But I want to be able to access each one of these services and demo you to make sure the REST points are working and all that stuff. So an easy way to do that is to expose each service via a node port. So instead of using cluster IP, I'm going to just configure this slightly to expose the service as a node port. So really, the cool way to do that is just via some configuration properties. So decorate Kubernetes service type is going to be node port. Okay, that's the only thing I'm going to do. And now I'm just going to build this thing so it generates our YAML. So I'm going to cd into the fashion app. And I'm going to run maven clean, oops, not caps lock, clean package. And then I'm going to do something that no one should ever do. I'm going to skip tests.
Never.
In the interest of time, I promise. Everything passes. I just want to make sure that we have enough time. So once that runs, if we look in the target folder here under classes, meta-inf, decorate, we have this YAML file. All right, and for those of you who love YAML, you'll be very excited about this. But I'm very excited mainly because I didn't have to write it all, and you didn't have to watch me do that. So it generates a lot of things, right? Like I said, it inspects things like the port, the server.port property to come up with the container port, the right container port. It sees that Actuator is on the class path, so it automatically sets up liveliness and readiness probes for Kubernetes. It determines the image name based on my username from my machine, as well as the application ID and a handful of other things here. It sees that, we'll explain this a little bit later, it sees that Spring Cloud Kubernetes is on the class path and creates some role bindings and service accounts for Spring Cloud Kubernetes to use. So it does a lot of stuff that I would have had to do by hand that I'm thankful that I don't have to do. And I'm sure you are all also thankful that I didn't have to.
That's enough YAML for today.
OK, so we want to get the app deployed to Kubernetes. So I have, for those of you not familiar with Kubernetes, a really easy way to get started with Kubernetes is if you're on a Mac or Windows and you use Docker Desktop. If you go to Docker Desktop and you go to the preferences here, there's a Kubernetes thing here, right? You can just click Enable Kubernetes, and it sets up a local Kubernetes cluster for you, which is really nice and easy for development. So that's what I use. I really like it. I like it a little bit better than Minikube. I've had a lot less issues with Docker Desktop than I have with Minikube. So I have that running on my machine. I have this other nice little tool called K9s, which is just going to kind of give us a visual representation of things that get deployed to Kubernetes, the local Kubernetes cluster. Okay. So what I'm going to do is use kubectl to create or deploy that YAML file. So it'll be easier if I do this. Create. There. So that's our YAML file that was generated. If I run that, yep. Yeah, I had mentioned earlier that I already did all that stuff. Built the Docker image, created all that stuff ahead of time, just so we're not doing that live.
Just regular stuff.
Yeah.
Nothing fancy.
Yeah, there's nothing special about that. It's just because it's plain old building Docker, right? Okay, so we can see that we got our deployment here for the fashion service is there. The pod will hopefully come up fairly quickly here for that deployment. You'll also see that so the pod's up, right? So there's a service that got created as well. See that service is here. And if we look at that service, we'll see that it has that node port exposed here, right? So here's the node port for the fashion bestseller app. So we can hit that node port. So if we go to that port / fashion / bestseller, there. So the app is running in Kubernetes and returning the data we expect. So now we want to do the same thing for all the other apps, right? So the cool thing is that once you've done it once, it's really easy to do it again. And the reason why it's really easy to do it again is because I created a patch to just do it. So instead of having me go through do the same stuff for each one of the other apps, I'm just going to apply a git patch on top of this thing that's going to do all that stuff that I just did for the fashions app for the other apps, okay? Just in the interest of time, I just want to save everyone the pain of having to watch me do that. Okay. So apply that patch, and like we said, just to make sure, you know, if we look at the gateway POM, for example, we have the Kubernetes starters as well as the decorate starters somewhere in here, top maybe, somewhere. There, right there. So, and then also, each one now has a application Kubernetes file with the same stuff in it that we had before in the fashions app, okay? And again, I've already built all the Docker images for these apps and it's in my local Docker registry, so we don't have to do that. But what we do have to do is run the build to generate the YAML files so we can deploy all these apps to Kubernetes, right? So I'm just going to go, which directory am I? I'm in the right directory.
Yeah.
Yep. I'm going to run same Maven command again. Don't. Nope. Nope. There. Don't do this at home.
Yeah, forget about this part.
And that all happened. So now each one of these apps also has their Kubernetes YAML created for them, right? So now all I need to do is get these all deployed to Kubernetes. Oh, one thing before I do that. So you remember how I enabled Chaos Monkey in the toy service, and I hit that Actuator endpoint to do that when I was running locally? Well, I want to demo one of the other things that Alex talked about, and that is externalizing configuration via config maps. So I'm going to externalize the property to enable Chaos Monkey to a config map, right? So if we look in the Toys Bestseller app here, I have this config map.yaml, and this is just a YAML file, as you might expect, for that property. And so once Spring Cloud Kubernetes is enabled, it will look for a config map of with the name of the application, in this case, Toys Bestseller, and apply any properties that it finds in there as a property source in the boot app. Right, so I'm going to create this config map as well in Kubernetes. So kubectl create, and here, that's our config map. So if we now go to there, we see we have that config map, and if we look at the YAML, we have that set to false, right? Okay, so just keep that in mind. And now we're going to kubectl create fashion, so toys, kubectl create hot deals, and then kubectl create gateway. All right, so, oops. So we have our services for all those. We'll come back to that in a second. We have our deployments for everything. So as everything comes up here, so we have the Toys app running, Hot Deals app is running, Gateway's coming up as we speak. So let's go back to the services, and we'll look up some node ports for these apps. So for example, Hot Deals, we'll see that the node port is here. So HP blah, hot deals. There we go, that's working. Let's look at the Toys app. And This is the node port for that. And I'm going to do a couple other things with this Toys app first. So one thing I wanted to show, so Alex had mentioned about the integration with the health endpoint, the Actuator health endpoint. So I'll show that real quick. Localhost /Actuator/health. So you can see if we scroll down here, we have a Kubernetes item here, which is providing you some details about the pod specifically. So that's pretty cool. Also show you the environment. Oops, not ENC, ENV. Here's our config map, right, with our Chaos Monkey enabled equal to false. Okay. I'm going to go into, I'm going to go back to our config map here, and I'm going to edit this config map. Okay. And I'm going to change the property from false to be true. So true. And okay. And you'll see that if I refresh this, the value got changed to true. So you have automatic refresh as you change values in your config maps. That will automatically be reflected in the application. So again, that's part of being cloud native is externalizing configuration like that and changing it on the fly. So that's all working. So let's make sure that, go back here. Let's make sure that the actual data comes back here. So if we hit that app /toys/bestseller, we got our data from the toy service. So let's just check out the gateway. So here's our node port for the gateway. We'll just do the start page for now. Okay, so we can see everything. Of course, first time Chaos Monkey, well, everything decided to die there, but there we go, we got all the data for all the services through our gateway running on Kubernetes. And eventually, the Toys service should hang itself, right? So we get the fallback working as well, right? So that's our configuration map changing, enabling Chaos Monkey, and showing that. And I think I covered everything, right? Yeah, all right. Good. Okay, I got everything. All right. It seemed to go too smoothly for for a demo. All right. So I'm going to hand over to Alex, and he's going to demo some other cool stuff.
Thanks. Yeah, so no surprise, it was working. But what about adding a database to this application, right? Because any real-world application would use a database. So let's do that. So first of all, I'm about to use another Kubernetes cluster. So this one is using PKS, Pivotal Container Service. And this cluster is hosted on a GCP tenant. So we are doing here live, and the cluster is not running on this laptop. So hopefully the network is good, and everything should be fine. OK. So first of all, I want to add a database. So let me show you kubeapps. So what is kubeapps? Kubeapps is an open source project from Bitnami, now VMware. So this is a Helm dashboard that you can deploy on any Kubernetes cluster. And the nice thing about this tool is that I can easily deploy any services as long as your services are available as Helm charts. So let's do that. Let's click on the catalog. Here you can see that I can just create about anything. So let's create a PostgreSQL database. Here you can see the page. I just need to click on this, deploy. I would then give this database a name. So let's use S1P, right? And let's add a password for this database. So again, don't do this on production.
You make the text a little bit bigger?
Change me. Yeah, I'm okay. I'm getting used to the...
No, the text on the screen.
Oh, is it readable for everyone? Yeah. Oh.
Command plus.
Command plus. Okay. So hopefully you should be able to read. So where was my password? Now
Sorry.
I need to. All right. Okay. So change me, right? And let's give this database a name. Let's call it S1P. All right. And that's about all the things I need to do. Just click on submit. And in a couple of minutes, a new database will be deployed to my Kubernetes cluster. So now let's switch to my cluster. Oh, again, it should be readable. Okay, so here you can see that I have a bunch of pods running on my Kubernetes cluster, right? And the S1P database is about to be deployed soon. But meanwhile, let's go back to the IntelliJ. And in order to go faster, I already created a branch called GPA. And let me show you what I've done. So here is the domain model classes. So the only thing I had to do is just basic Spring Data GPA. So here you can see that I just added annotation, GPA annotation, right? Nothing fancy here. And in the toys bestseller application, I am leveraging Spring Data GPA and Spring Data REST, as you can see here. So I can just use my database, and I will connect to this database and use it with my application. So let's check if everything is running. All right. So I have my database here running. So I want to check that everything is working fine. So let me just connect to this database. So I'm using here this command, kubectl port forward. So I'm opening a connection between this laptop and the remote Kubernetes cluster. So I want to connect to the database, and the name here is over there. So S1P-PostgreSQL. All right, and I want to open. Oh, sorry. I want to open a port. Okay. So from this point, if I connect to this port, I will just connect actually to the remote database. So let's do that. Let's create a new database. Oh, let's remove this one, maybe. We will start from scratch. All right. So let's create a new data source.
Sorry.
Oh, do you have something to zoom on the screen? Maybe so.
Maybe. Option. What option? Zoom in. Option.
Let me do this. Let me do this like this. Maybe we can just
Oh,
click
yeah,
on Control, and then we can
Okay.
zoom. All right. So hopefully it should be readable for everyone. So I am connecting. So let's remember that I was using this user. The password is change me. All right, and the database name is S1P. So let's connect to this database. Fine, everything is working. So now you can see that from my workstation, I can connect to the database, and as you can all expect, the database is empty. So let's connect my application. First, I will connect an application running locally on this laptop to the remote database, just to make sure that everything is working. So in order to do that, I will just copy paste the GDBC URL, because I'm about to use it in a second. So, and there is everything already set. That's fine. So as you can see here, when you use Spring Data GPA, you need to add some attributes, right? So Spring Data Source URL to say how to connect to your database, and then you need to set the database credentials. But it's already set on this property. So just start the application now. All right. So my application is starting now. Here you can see that Spring Data GPA, so that my application was connected to some database running on my Kubernetes cluster. So the right Hibernate dialect was selected. All right. And then we can just refresh the schema. All right. Let's hope the network is working. All right. And then we have the product table as expected, right? So my application is still running on my laptop. So the next thing I want to do now is to publish everything that was running on the Docker desktop local Kubernetes cluster. I want to push this application to a real Kubernetes cluster running on the cloud. So let's do that. In order to do this, I have a ready-made script. Here you can see. So I'm about to run this script. All right. So we have a bunch of pods now that are about to be deployed. Here you can see that fashion bestseller is starting, and you can also see that I created a load balancer object in order to access my application. So here I'm asking the Kubernetes cluster to give me an IP address so that I can just connect to my application using a real-world IP address. So we just have to wait for the Kubernetes cluster to give me this address. So in the meantime, let's check that everything is working. All right, all pods are running. And I have my IP address here. So if I hit this endpoint, oh, is it the right? Yeah, we'll figure out in a minute. So now I want to use the GPA stuff that we added earlier, and I want to publish this Docker image to my Kubernetes cluster. So let's edit the deployment of toys bestseller, and let's see if we can find the image. Where is it? All right. So I already built a Docker image for the GPA stuff, and my Docker image was published to some Docker registry running on the cloud. So here you can see that I am using Arbor. Arbor is a Docker registry from VMware. It's an open source project that you can also deploy to just any Kubernetes cluster. And using Arbor, you will have nice features like image scanning and a lot of fancy stuff. So here you can see that I have an image already deployed. So what I need to do is just to get this, and I will replace the image with the one deployed to Arbor. So my Arbor is deployed on this public endpoint. All right. How to exit VIM? Just a question for every developers. Okay. So here we have the pods, and here you can see a new pod is about to be deployed for my toys bestseller. And while we are waiting for the pod to deploy, in the meantime, what I want to do is to connect my application. So I would just edit this config map, just as we saw earlier. Here you can just recognize the chaos monkey enabled fit property. So let's just add the same attributes that we set when we were running the application locally. So you know the property. So let's set the URL. All right, and let's be lazy and just copy paste this template. All right. Of course, the database is not running on localhost, so I need to get the service name, and the service name is set here. All right. Then I need to set the credentials. Okay, so there you are. And finally, I need to set the password. All right, everything should be okay. Just make sure that I'm using, oh, where is it? On this American keyboard. All right, I found it. All right. All right. So since I've touched the Spring Data GPA configuration, this is a special case here. So I need to restart the pod because there is a pool of JDBC connections that were opened by Spring Data GPA. So actually, I need to delete this pod only for this use case. So let's do this. And while this pod is about to be terminated, a new pod instance will be started. And this time, this pod will be connected to my database. So just cross fingers, everything should be okay. Let's see if we have everything running. So let's just, can I just kill this one? Yeah.
Yeah.
Okay.
Yeah.
Already done.
We're not going to use it.
Okay. Okay, it's running. All right. All right. So now we will just connect to the, sorry. And the IP address is not good, so this is the IP address I need to use. All right. Here you can see I am connected to the database. All right. So let's add a new let's add a new entry. Oops. I don't think it's the right one. Excuse me. Where is it? I think I missed it. No problem. Let's create a new tab. Yeah. This might not be the right time to update. All right.
Good decision.
Yeah. All right. This is not what I was expecting to do. Where is it? We have to figure it out. Okay. I'd like to post, so I need to get the.
It was post to Spring Data GPA.
Yeah.
It was that first one you searched past.
Oh, yeah, but I lost the. Anyway. All right. What it is?
To the gateway, right?
To the gateway. So.
Toys dash bestseller.
Toys
Dash
dash
bestseller.
bestseller.
Slash JPA.
Yeah.
Slash toys.
Slash toys. You're right. Name. So let's do this. Name equal to. Let's create a Lego Josh Long limited edition. On with this category. All right. All right. It's working. So let's check that everything is working. So I would just update the database, and then you can see. So my application is really connected to my database. So as soon as I interact with my application using the REST controller that was generated by Spring Data REST, when I do SQL insert query, just like this, you see that my application is actually connected to the database. So it's just a matter of adding the right dependencies to your application, and then you just need to set the credentials to connect to your application, the same credentials that you would be using if you were connected to your database using your workstation locally. And in the end, it's just basic stuff. You just edit the config map, and you're done. You're connected to your database. So let's go back to the slides, Ryan, to conclude there.
Okay.
Thank you.
So do I need Spring Cloud Kubernetes? It's kind of an odd question to ask in a session about Spring Cloud Kubernetes. Well, if you are really deeply familiar with Kubernetes, you probably know that, well, I can do service discovery via DNS. I can, mount config maps into my application via volumes, and as long as those config maps are configured in like a YAML format in a place that the boot app knows where they are, it will work. The refresh part, that's unique to Spring Cloud Kubernetes. When I changed that property and automatically saw it reflected in the boot app, that's unique to Spring Cloud Kubernetes, but you can also make the argument there that this is a cloud platform. These apps are, we don't really care about them, so I can deploy, get another instance up and running, kill the old one with the old configuration, and just, let that happen. Load balancing, we don't really need Ribbon. We have that at a service layer. That's, a difference there is that with Ribbon or the new Spring Cloud Load Balancer, that's all client side, and if you're taking advantage of the service itself from Kubernetes, that's platform based, and there's different types of load balancing that could be enabled depending on how your admin configured Kubernetes. So there's a little bit of an unknown in what amount of control do you want to give up as a developer. I'm not sure. So you can make an argument that, well, everything that Spring Cloud Kubernetes does can be done natively with just Kubernetes concepts. And it's a perfectly valid argument. Today, what we do under the covers in Spring Cloud Kubernetes that you might have kind of seen if you're very observant when we were looking at the YAML files is that we use a client, a Kubernetes client, Java client, to communicate directly with the Kubernetes API server under the covers to do some of these things. And in some cases, that might not be okay, right? Your admins might say, I don't want my apps talking to the Kubernetes API server. I don't want to allow that. So that could be an issue for some people as well. So basically, as it always comes down to in development tasks, you got to use what is right for the situation that you're in, right? If you're taking existing applications that are using Spring Cloud that have, using Discovery client, they're using Ribbon, they are used to using or already use a client-side load balancer, and it's okay to use the Kubernetes API. You can use Spring Cloud Kubernetes, right? It works. It's going to make that transition, as you saw, very smooth, right? We didn't touch any of the code at all. We just added some configuration properties, a couple dependencies, and things worked, right? If you're very Kubernetes savvy and this is a brand new application, it's not using Spring Cloud already, and you just want to run, taking advantage of what the platform offers, you can do that today, right? There's some caveats, right? There's some things that might not work exactly the same, but you can certainly do that, right? So the choice is really up to you and what you want to do, yeah. So we just want to make sure we use the right tool for the right situation. Obviously Spring Cloud Kubernetes is a very new project, and we're going to evolve it, and perhaps there might be different implementations of some of these things that don't use the Kubernetes API directly in the future, and that's something we're talking about and looking into. So you can look forward to that in the future, and if anyone has any input, wants to give us any feedback on that, feedback is always welcome. Please reach out to us and let us know. And with that, before I open up for questions, you can always reach out to me or Alex on Twitter. We're always happy to help. Obviously, we're going to be here for the rest of the week, so find us and ask questions. If you're interested in another Kubernetes session, there's another one this afternoon at 2, which I highly suggest you attend. The source code for this is all on my GitHub repo there. There's a README with all the details and all that stuff. The slides, you'll get a copy of those slides. And this is all recorded, so it will be up on YouTube in very soon, so you can review that as well. And with that, I'll open up to questions if anyone has any questions. Yeah. Yep. Yep. Yeah, we allow that same thing in Spring Cloud Kubernetes. Yep. Yep.
Can you elaborate a little bit more on the service mesh?
Thank you.
On the service mesh, because the container and the service communication, do they need to go through the API gateway, or they can directly communicate?
So there's no real service mesh there, right? We're using the concept of a Spring Cloud Gateway, right? If you use a service mesh like Istio, for example, there's another layer of complexity that gets added in. We don't do anything smart there when something like Istio is present, right? So if you have use cases for something like that, I'd love to hear them and talk to you more about that. That's not something we've tackled yet. Okay? Yep. Sorry, I can't hear what you're saying.
The GA version is 0.30.
So we don't use version numbers. You have to use the Spring Cloud BOM. Never use the version number directly.
Never, ever.
So it's Greenwich SR3 is the current GA version.
My question was more of, there's a lot of changes, scanning across multiple namespaces and things that all in the 1.0 version of the Spring, again, I know.
Okay.
So when does that become a GA, right, with what Spring?
Are you talking about Kubernetes namespaces?
Yeah, on the Spring Cloud.
Is there a specific change a specific change you're talking about specifically, where are we talking about this service discovery across namespaces? I think that, I'm pretty sure that change is in Greenwich SR3. If not, it will be in Greenwich SR4. I can't remember off the top of my head, though.
Okay.
Yeah. It was merged. I know it's merged
Recently?
and I can't remember if that was merged before we did SR3 or if it's, we haven't done a release with it yet. But it will be fairly soon, within weeks, probably. Yep.
This is related to how Spring Cloud Kubernetes manages the YAMLs generated from decorators. So if the user wants to add some customized field or configs, how would you handle that?
So customizing the YAML that decorate generates?
Yes, from the generated read.
Yeah, so it's all configured via configuration properties.
Yeah.
So if you remember back to where I
actually, I think you understand that you don't have to use decorate with Spring Cloud Kubernetes.
you don't have to.
You
yes.
don't have to. If you really want to write the YAML files by yourself, it's up to you,
Yeah.
right? We used decorate in this demo to go faster and to generate these files for us because we are not YAML architects, so.
But yeah, if you do want to customize it, it's all done via configuration properties. So that decorate Kubernetes, that's how I change, for example, the service type. Okay, that was generated. Yep. Yep.
So you need to give permissions for the API of Kubernetes for the different.
Yeah,
Yeah.
that's
yeah.
right.
Different granularities, or is only like
There are different granularities, so different.
It's all, everything is documented
Yeah.
on the website. So
Yeah, that's all.
you'll find the details.
Kubernetes stuff. So if you look here.
mostly REST, or you also need to
No, just reading.
Just reading,
Just reading, yeah. So you have this cluster role. Where is it?
okay, this is the document.
Yeah, it's there.
You'll
Sorry.
find the details, yeah.
I can't find it in the C of YAML. Yeah.
So if I have a Spring Cloud gateway and I want to would I use the Spring Cloud Kubernetes ribbon project as well? Like what do I
Yep.
get out of that besides like just use regular service the load balancing and Kubernetes?
Yeah, so it's whether you want the load balancing client side or you want to just let the platform take care of it, right? So if you use Ribbon, for example, you as a developer could have control over the algorithm that's being used. If you just rely on the platform, it's going to be whatever the admin of the platform is configured. So yeah.
Yeah.
Yep. Yep.
Yeah, with
Any
that,
other questions?
thank you everyone.
So the annotation
Oh.
that I use, like enable Eureka client, those kind of things, still be there in the code, or they're not required?
So that enable Eureka client and enable discovery client annotation is no longer required. So you can take it out of your code, actually. It just gets triggered when the dependency is on the class path. But the application will build fine, right? But you'll just have to disable Eureka when you, like we did in the app, when the profile is enabled. Yeah, so you can leave it there. It's not required. You can take it out, actually. So you can go back and do that when you get back home. Anyone else have any questions? Yep, we have to. I
One
think
more.
we're getting kicked out. Yeah.
Well,
Yeah. Last question. Go ahead.
I have a question about service discovery.
Yeah.
Yeah.
What's the difference between using discovery client or just using service name?
Using the service name. So just the difference between using the discovery client, Spring Cloud discovery client, or versus not using discovery client and letting Kubernetes resolve the service name, the DNS for the service name. Is that what you're talking about? Yeah. In one case, we, under the covers, are fetching all the pods for that service via the Kubernetes API client and returning that information to you. In the other case, we're making a regular REST template or web client request and letting the Kubernetes DNS resolve the IP address for that service and letting the service route the request. So yeah, that's the difference.
you have choices.
Yeah. Okay, we're gonna boot it out of
we
the room.
have
So
to. Thank
thanks
you,
everyone.
Bye.
Appreciate it.